So once again, if you notice, we don't have a warm-up today. We're going to go straight into our study guide. We're going to continue on number 13. We're going to go out of our study guide for this one. Here we go. Let me zoom out. And it reads, answer the question by writing an equation, so underline that. They want us to write an equation. And also determine whether the solutions of the equation are real, circle that, or non-real. Hopefully that rings a bell, is that correct? Yeah, because the last problem that we left off yesterday, we looked for if they were real or non-real. But now we're going to apply to a word problem. Here we go. It reads, a gardener has 140 feet of fencing to put around a rectangle vegetable garden. The function AW equals 70W minus W squared gives the garden's area in square feet for any width in W in feet. Does the gardener have enough fencing for the area of the garden to be 1,300 feet? So first things first, let's write our equation given. Write the equation given, which is A of W equals 70W minus W squared. Next, we need to substitute a value, whatever value that they give us. What do they give us? It says the gardener has enough fencing for the what? Area to be what? 1,300. So where would we substitute that in our equation? For the area, where would I substitute that? Here. That's the A for area. So I would write what? 1,300 equals to 70W minus W squared. So, second thing. In order to solve a quadratic equation, it needs to be equal to what? 0. That is correct. So what do? Subtract 1,300 to each side. Subtract 1,300 to each side. Now look up really quick. This is 0, yes. But on this side, I want you to write it in standard form as you're rewriting it. Rewrite this in standard form right there. Therefore, you should have written negative W squared, yes? What else? Plus 70W, and then at the end, minus 1,300. Now, believe me or not, we're not going to solve that equation. Why not, Mr. Q? Because look what they're asking. They say, answer the question by writing an equation. Did we do that? Yes. And tell whether the solutions are what? Real or non-real. What can we do with this to find out if they are real or non-real? Tell your neighbor, please. Yeah, I heard a lot of conversation. Back there, I heard Lenny and Pam, they're like, oh yeah, Mr. Q, B squared minus 4AC. Yeah, that is correct. That's what we use to find out if the solutions to a quadratic equation are real or non-real. Yeah? Therefore, that means we need values. Where do we get those values? From here. So underneath here, I'm going to write my standard form. AX squared plus BX plus C. Now, really important, guys, the reason we write this down here, because some of you, check this out, look what your brain's going to do for some of you. You're going to want to substitute in here -1. Tell your neighbor why that is wrong. Yeah, because -1 corresponds to A, not what? B. What is B? 70. And what is C? 1,300. So be careful. Identify first your A, B, and C, then do the substitution. So here we go is 70, -1, and -1,300. So be careful with that. Yes, Mr. Q. All right, good. So, 70 squared, that's 7 times 7 is 49 with 2 zeros. Okay. Negative times a negative is a positive 4. 4 times negative 13 is negative 52 with 2 zeros. Okay. So, negative 5200 and positive 4900, that gives me negative 300, yes. Woo, let's go. Remember what that means. It means what, guys? No real solutions. So what kind of solutions do we get? Imaginary solutions, right? But are we looking for imaginary solutions to this problem? No, it has to be a real. So if there aren't any real solutions, how can we answer this question? Does the gardener have enough fencing for the area of the garden at 1300? Tell your neighbor what you're right for your answer, please. Yeah, I heard the gardener does not have enough fencing for the area given, 10 cubed. And of course, once you show me this part, look up, and you write this, that lets me know that you understand why you wrote that answer. However, what if it was a positive number? What would your answer be right here? So, if this was a positive number, what would you write at the end, Brooke, for your answer? Yeah, the gardener does have enough, right? If there was a positive number. Okay. Say it again? It might be a little bit more, but does he have enough? Yeah, enough or more than enough. Yeah. All right. From 1 to 5, I'll come to bore you with these. Okay, so what is the only thing that we did? We wrote our equation, substitute the value, set it in standard form, and then just use the discriminant to find out if it was solvable. Did we have to solve anything? Not really. We just answered the question. All right? Next, let's go to our blank sheet of paper. I want you to write example 14Q. 14Q. Then I want you to write the word rectangle, length x, width 7x cubed plus 11x squared minus 5x plus 2. And then they're going to ask, find perimeter. Okay? So when you get to this one and they want you to find the perimeter, first thing I want you to do is draw a picture. Ready? Okay, here we go. Let's see, I'm going to draw a picture. Draw a picture of a rectangle, my goodness. See, what is this? To draw a picture. Anyway. Alright. What would I label this one? X, and this one, and this one. 7x cubed plus 11x squared minus 5x plus 2. That means this is also 7x cubed plus 11x squared minus 5x plus 2. So, now that we have our rectangle label, tell your neighbor how to find the perimeter. Alright, Sky, how do we find the perimeter? Bree, help her out. Do you hear that? She said you add all sides. How many sides? 4. Side plus side plus side plus side. Any figure, when they ask you to find the perimeter, you just add all the sides. So, perimeter. For the sake of space, I'm going to stack all the expressions and then add vertically. So what's my first one? I'm going to write this. 7x cubed plus 11x squared minus 5x plus 2. I write it again. 7x cubed plus 11x squared minus 5x plus 2. So I got these two down. What's next? X right underneath the x term. And then x. We're going to combine. And that's going to be my perimeter. Alright, let's see. 7x cubed and 7x cubed, that's 14x cubed. 11x squared and 11x squared, that's 22x squared. Negative 5x and negative 5x, that's negative 10 plus 1x plus 1x. What is it? Negative 8x, yes. 2 plus 2, that's 4. And that's the perimeter. However, find the perimeter if the length is 10 yards. So, which one of these sides is my length? The x. So we would label this one 10. Which means what do we need to do in here? Tell your neighbor, please. Bless you. So instead of x, what do we write? 10. Yes. Therefore, perimeter, let's see, 14 times 1,000 plus 22 times 100. 8 times 10, that's negative 80 plus 4. Perimeter, we got 14 times 1,000, that's 14,000 plus 2,200. And then we got negative 80 plus 4. So, what's my perimeter? All right. Share with the neighbors, see what they got for their perimeter. We got it? Yes? Okay, good conversations. My goodness. All right, Philip, what'd you get? Hands, if you got that? That is correct. Don't forget the unit of measure, or else I'm going to dock you a point. Yes? So with that said, I want you to go to number 14 on your study guide. Do number 14. Make sure you label your stuff, set it up. All right, I'll give you some time for that. Go. All right, there's number, what was that one? 14. So number 14, once again, in passing, make sure you draw your rectangle, run underneath, just to save time and save space. That helps out. Then you set up your perimeter, substitute values, and so on and so forth. And unit of measure. So, on your blank sheet of paper, example 15Q, copy this. Let's multiply 13 squared. But we're going to use identities. Yay, our favorite, yeah. All right, first is first. We need to write 13 as a binomial. It can be written as 10 plus 3 squared. Yes? Now, according to the identities that you memorized, right? I had you guys memorize some identities. Okay, good. There's one identity that looks like this. X plus y squared. Yes? And that one becomes x squared plus 2xy plus y squared. Yeah, it's right there in your study guide. So what does that mean, Mr. Q? That means that x, I first write it squared, and then I multiply 2 times x. Then the y, I multiply 2 times x times y, and then at the end, y squared. However, now instead of those, what do I have? Instead of y, I'm going to have what? 3, and instead of x, I'm going to have 10. Which means I'm going to follow this pattern by using these numbers. So, something squared plus 2 times something something plus something squared. Yes? So, Andy, go. What do I write here? Ten. 3, yes. And then we just simplify. This is 100 plus 60 plus 9, and this is 169. You're like, what? So, which means that this one, if I wanted to check old school, 13 times 13, that's 3 times 3 is 9, that's 3, 13, that's 116. Oh yeah, there it is. Yeah. But today we're using what? Identities. So, go to number 15 on your study guide, do number 15 by yourself, using the identity. And yes, if you already did it, do it again. Give you some time for that. All right, and once again, they give you the identities, you just need to match it. Yes? So which one does it look like? 20 plus 3 looks like this one, which means you take this and write it with numbers. Now, in the other, earlier today, a student saw, Mr. Q, can I write this another way? Sure. 30 minus 7 squared. What is 30 minus 7? 23. But then I cannot use this one because this one is x plus y. What is this one? X minus y. Is there one that looks like that? Yeah. Right there. Anyway, fun stuff, yeah? All right, on your blank sheet of paper, copy this, example 16Q. 16Q. Let's multiply 28 times 38. But before you multiply it, we're going to use identities. Oh, yes. So what is the first thing we need to do, Mr. Q? We need to write these as polynomials or binomials. So, in order to do so, pay attention to this part. We need to first identify the number that is right in between those two numbers, to use that same number for both. So you can think about it. You can draw a number line, or you can do the following. Take the largest number, subtract from the smallest number, and that gives you the distance from one number to the next. But is that what we need? No, we need the number where? In between. So that means we need to divide by what? Divide by 2 to find that middle ground. So what is that middle ground? 5. Is that the number, Mr. Q? No. That means that the number we're going to find it is 5 steps of each of these numbers. So what is that number, everyone? 33. That is correct. 33 is 5 steps from 28 and 5 steps from 38. Now that we have that number, we can write each of these numbers as binomials using the number 33. So, 33 and what gives me 28? Minus 5. 33 and what gives me 38? Plus 5. Are we done, Mr. Kid? No. Look at the identities on your study guide. Which one looks something like this? Did you find one? Yeah, x plus y, x minus y. Do you guys see that? And what is the answer for that one as a product? X squared minus y squared. But in this case, instead of x, what do we use? Yes. And instead of y, we use what? 5. Therefore, 33 squared minus 5 squared. So, what is 33 squared? 33 times 33. $1,089, yes. Minus 5 squared is 25. Therefore, this is 1,064. Do number 16 on your study guide by yourself. See what you get. Give you some time. Work is on the screen. That number was 38 and 38, yes? 38 minus 4, 38 plus 4, then therefore 38 squared minus 4 squared. 38 squared is 1,444. 4 squared is 16, so 1444 minus 16 is 1428. Hands, have you got that? Okay. So, you can take, yes? Yeah. Does it work if the what?
The y, instead of having 4 and y, now y is negative 4.
Oh, you mean doing 38 minus negative 4? and 38 plus negative 4, like that? That works. But isn't this that? Yeah. All right. So, on your blank sheet of paper, write this down. Pascal Triangle. Let me get you guys started. Here you go. Bam. I turn around and they make eyes at me. Why? Be nice. Here we go. 1, 1, 1. Remember these, yes? Combine these. 1 plus 1 is 2, and then 1's at the end. Combine these two, that's 3. Combine these two, that's 3, and then 1's at the end. Combine these two, that's 4. Combine these two, that's 4. But how about this? 3 plus 3 is 6, and then 1's at the end. Combine these two, that's 5. Combine these two, that's 5. However, 4 plus 6 is 10, and 6 plus 4 is 10, and 1's at the end. I'll stop right there. This is a Pascal triangle. Now, check this out. Why is this so important, Mr. Q? Because we need to identify the row that we're going to need. Now, check this out. This one that we started with, that one is row 0. That means that row 1 is that one. Row 2 is this one. 3, 4, 5, and so on and so forth. And a way of identifying it a little bit faster is like this. Skip the first one, then this is row 1, 2, 3, 4, and 5. Okay? Now, why is that so important, Mr. Q? Well, check this out. They're going to ask you pretty soon to multiply that stuff that looks like this. Look up. X plus 9 to the 3rd power, for say, by using identities or using the binomial theorem. So why do we need to know this, Mr. Q? Because this exponent tells us the row that we need to use. What row? 3. That means we're going to use these 4 numbers for the multiplication of that binomial. So if I was to give you this other one that looked like this, 3x plus 5 to the, give me a number? 5. What is the row? 5. What numbers are we going to use? All of these, Mr. Q. That's why we need the triangle. So cover that up with your hand. Here it goes. And I want you to write the Pascal triangle again. I'll get you started. There you go. See if you can do that by yourself now without looking at your notes. We good? 1, 1, 1. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, and 1. And I'll stop right there. Yes? One more time, or are we good? Yeah? We good? Or tonight you can make it a family math night, do index cards and pass them the Pascal triangle, you know? All right, here we go. Example 17Q, write this down. 17Q. And let's use x minus 3 to the 4th power. And then right above that, I want you to write binomial theorem. So, whenever you see this, right away, you identify that you need what row? 4. So right away, you're going to build your Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and you stop at what? 1, 4, 6, 4, 1. Because we're going to need these. Y'all ready? All right, here we go. This is how you use them. These are coefficients. So we start and we write over here 1, empty space, plus 4, empty space, plus 6, empty space, plus 4, empty space, plus 1. Does everybody see that all of these are these? Yes? Okay. Now, let's see. You're going to be like, oh, I remember these. So check this out. I'm going to use blue for my first term. What is my first term? X. So I'm going to write x to the 4th for the first term. That means here I'm going to write x to the 3rd. That means here I'm going to write x to the 2nd, and then x to the, and x to the 0. You're like, oh, I remember these, right? You're like, yes, they're my favorite. Next, second term is -3, so I'm going to write it in parentheses. -3, but look the exponent that I'm going to start with. Not the 4th power, I'm going to start with the 0 power. And that one, the next one would be what? -3 to the what? 1, -3 to the 2, -3 to the 3, and -3 to the 4. Now that we have it set up, now we multiply and simplify. Ready? Here it goes. I'm going to use black for the whole thing. What is -3 to the 0 power? 1. Anything to the 0 is 1. So what is 1 times 1? 1. So that leaves us with x to the 4th. Next, what is -3 to the 1st power? Well, it's still -3, Mr. Q. So what is -3 times 4? -12. Bring down the x to the 3rd. Next, what is -3 squared? -3 squared is what? 9, yes. And then multiply 9 times 6. What is 9 times 6? 54x squared. Next, what is -3 to the 3rd power? Tell your neighbor, -3 to the 3rd power. All right, Miguel, -3 to the 3rd power. -27, that is correct. Then we multiply that times 4, that gives me -108. Bring down the x to the 1st. Last but not least, -3 to the 4th power. That means -3 times -3 times -3 times -3. That is, Carlos? 81, that is correct. What is 81 times 1? 81. And what is x to the 0? 1. So what is 81 times 1? It's still 81. Go to number 17 on your study guide. Do that one by yourself, please. And that's how you use the Pascal Triangle for the Binomial Theorem. All right, let's see what we got. Who got x to the 4th, -8x to the 3rd, plus 24x to the 2nd, -32x to the 1st, plus 16. Yeah, we got this, yes? All right. So let's go to number blah, blah, blah. Oh, 18. Let's go to 18. All right. So for 18, just for the sake of time, I'm not going to draw my triangle because I know which row I'm going to use. Is that correct? And by now you should be able to memorize it, that it's 1, space, 4, space, 6, space, 4, space, 1. Next, what's my first term? 2x, which means hopefully you did parentheses 2x to the 4th. Because if you just write 2x to the 4th, you're only going to leave the exponent on the variable. Careful with that. That means this is 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and 2x to the 0. Which means my second term is negative y to the 0, negative y to the 1st, negative y to the 2nd, negative y to the 3rd, and negative y to the 4th. Okay, here we go. What is negative y to the 0? 1, and 1 times 1 is 1. Okay, so I just need to figure out this. What is 2 to the 4th power? 16. Yeah, 2 times 2 times 2 times 2. Yes. And what is x to the 4th? X to the 4th. Next, negative y to the 1st is still negative y. Why do I write it up here? Because look, I need to use this negative when I multiply all the numbers at the end. So let's see. What is 2 to the 3rd power? 2 times 2 times 2 is 8. What is 8 times 4? 32 times the negative, negative 32, x to the 3rd, and y to the 1st. Next, negative y times negative y is just positive y squared. So that leaves us only the numbers. What is 2 squared? 2 squared is 4. What is 4 times 6? 24, x to the 2nd, y to the 2nd. Next, we got negative y cubed, that's negative y. And then 2 to the 1st, that's still 2x, so that's 2 times 4, that's 8. Oh, but it's a negative, sorry. With this, it's a negative, so it's negative 8x y. And y to the 3rd, sorry. Okay. And last but not least, this is a giant 1. Giant 1, 1 times 1 is 1. And we're left with positive y to the 4th. There you go. Now, just in passing, guys, number 19, check this out. 19 is factor by grouping, as well as number 20. See, you should be able to do those. We did them on the warm-ups, and also 21 and 22. See if you can go all the way to that for today at your home place. Good one, guys. See you guys tomorrow. Bye.